Hello everyone, welcome back. So in this video, we're going to talk about the baseline derivation and uses. So a comprehensive guide for the clinical data programmers working with ADAM standards. Myself, Ali Sheikh, I'm working as a consultant at Trial Optima Inc. Okay, so the next slide would be, so the table of contents, overview of the baseline derivations, the common variables, base type definitions, and example scenarios, the baseline characteristics in ADSL, single baseline definition, and multiple baseline definitions. So this module aligns with ADAM model version 2.1 and implementation guideline version 1.1. Okay, so the introduction, the training module covers the ADAM model version 2.1, 1.1 rules for the creation of the rows and columns, rule number 6. The primary focus is deriving the baseline variables and records in ADAM datasets according to the standard specification. So ADAM model, so you can have some reference materials. Okay, so the overview of the baseline derivations. The baseline values serve as a reference points for assessing the treatment effects in clinical trials, providing the foundation for safety and efficacy evaluations. Okay. Okay, so the derivations and identification of the baseline values are oftentimes needed for the both and the safety and efficacy. So it is a multiple ways to include the baseline values in ADAPT. So examples, weight baseline, BMI baseline in ADSL. Okay. So baseline records are understood to be consistent within the parameter and within the dataset. Okay, so the fundamental rule for the baseline derivation is the rule number 6. When there is a more than one definition of the baseline, each additional definition of the baseline requires the creation of its own set of rows. So why this matters? Multiple baseline definitions are in common in clinical trials to accommodate different analysis needs and time points or populations. And implementation impact. This rule affects dataset structure, requiring the careful consideration in dataset design and population to maintain the traceability. And the documentation requirements, each baseline definition must be clearly documented and differentiated within the dataset to ensure the proper analysis interpretations. So the common baseline variables, one base, one change. So you cannot have multiple versions of the base or change in BDS dataset, like base 2 change 2. So the base contains the baseline values for specific parameters required when calculating the change from baseline. The change contains the change from baseline aval minus base, so required when analyzing the treatment effects. And the percentage change from baselines aval minus base slash base into 100, optional but commonly used for the relative assessments. So these variables must be consistent within a single analysis dataset structure. So understanding the base types, the definition and requirements, the differentiate between the multiple baseline definition within the same parameter or datasets. So required when multiple baseline definitions exist corresponds to the base value in each row. So the common use cases, different study periods require different baselines, change calculation between different study time points. So different definitions for efficacy versus safety endpoints, different analysis populations. So the base type will be having the different phases. You see, if when they have a number of study periods, you will be having different baselines. So records within the same parameter will have multiple sets of baseline related variable per base type values. So analysis baseline value base change. So this we already discussed in the previous video. So example 1, the baseline characteristics and covariates in ADSL. Subject level analysis datasets serve as a foundation for all the ADAM datasets containing the key baseline characteristics and used as a covariates in statistical analysis. So example 1, building ADSL with the baseline characteristics. The procedure, determine the baseline definition, last non-missing assessment prior to the first dose of the study drug. So the baseline definition will be the prior to the first dose of study drug, that would be the last non-missing assessments. So identify the needed variables, baseline height, baseline weight, baseline BMI, and ADSL metadata, variable names less than or equal to 8 characters, variable labels less than or equal to 40 characters. So end in BL. Okay, so baseline flag. So these are the characters. So these are the some ADSL metadata rules. So example, ADAM specification for ADSL naming convention. Baseline variables in ADSL follow standardized naming patterns ending with BL. So height baseline, weight baseline, BMI baseline. So this is the naming conventions. So implementation notes: baseline derivation should be clearly documented in the analysis data reviewers guide for traceability. In the next module, we will explore the single and multiple baseline definition in the BDS datasets. So this is the specification: height BL, weight BL, and BMI BL. Okay, so set a last non-missing in the vital sign standard is a numeric value where VS tested equal to height. So this is the programming derivation for creating this height BL, weight BL, and BMI BL. So the single baseline definition for BDS analysis: the sample test requirements, the laboratory test, hematology, and chemistry must include actual values and change from baseline by visit. Okay, so the shift from baseline to worst on treatment value using the low, normal, high classification and SI units for all presentations. So the implementation process like this: the step one, determine the definition of the baseline and worst on treatment value and identify all variables needed in the BDS dataset structure for the step two. Okay, so here the following summaries will be provided in each kind of laboratory parameters. So let's continue with that one. So if you see here, this is the output, one of the report. The hemoglobin parameters will be having a different time points. You see the baseline and the cycle and the change from baseline and based on the treatments. So here the table shall demonstrate summary statistics for actual values, change from baseline by visit treatment group, and require the proper baseline flagging in the analysis dataset. Okay, so the table shall shift from baseline to worst on treatment values. So this shift table present counts of subject transitioning between the reference range categories from baseline to worst on treatment value, requiring both baseline and worst flagging methodology. So the baseline definition: the last non-missing measurement prior to reference start date included unscheduled assessment. So worst definition: high, low, normal, missing hierarchy for determining the clinical significance. And on treatment definition: any non-missing post baseline measurement including unscheduled assessments. So the critical BDS variables for implementations: param, analysis visit and aval value, an analysis baseline flag, base change from baseline calculations, and baseline range indicator, baseline reference indicator, analysis 01 flag for the worst on treatment value, and the shift variable to categorize shift. So ADLB metadata specification example, you can see here there are variables: parapsody, analysis visit, aval, analysis baseline flag, base change, and analysis 01 flag, and we'll be having LB visit, LB standardized numeric format set to Y if there is flag. Okay, so this is metadata specification as an example. And the example ADLB dataset implementation results that this dataset accept demonstrate the implementation of the flags and derive variables required for single baseline analysis. So this dataset accept demonstrate the implementation of the flags derive variables required for single baseline analysis. So analysis baseline flag: the baseline records, last pre-treatment measurements, base values derived from the baseline records are carried forward to all records. So the change calculated as aval minus base for post baseline records, and analysis 01 flag identify the worst on treatment value for shift analysis. And the multiple baseline definition introduction. So some clinical trials designed require multiple baseline definitions to accommodate distinct study phases or treatment periods. So here the study design. So scenario 1, the study design challenge. The study comprises a double blinded period followed by an open label period. So need to summarize laboratory data with a change from baseline by visit both study periods separately. Okay, so multiple baseline approach: the last non-missing measurement prior to first dose of double blind period, and the baseline number 2, last non-missing measurement prior to the first dose in open label period. So the key implementations variables: standard BDS variable, so param, so and analysis baseline flag for both periods and baseline value for the respective periods. And the base types a critical variable to differentiate between the baseline definitions. And a period identifies study period change, period specific change from the baseline. So these are the key implementation variables. And this is an example metadata specification. So you'll be having analysis period, ABLF, base type, base change, and how we derive these ones. Okay. So the